everyone. In the last class, we had the discussion on structurally controlled failure in case of the tunnels with special reference to the failure in the side wall. I was discussing with you that how the construction of this full view of the wedge which may slide from the side wall of the tunnel can be carried out. So, we will continue with that discussion today, and we will try to see that what all are the methods which can be used for the analysis of such type of failure. So, we had discussed about the method number 1. So, in continuation to that, take a look here on these figure, that these line of intersections AB prime, BC prime and AC prime, as they are seen in the vertical side walls, these are also parallel to the lines from the center of the vertical projection of the points AB prime, BC prime and AC prime. So, we are talking about these 3 lines, you see, first one, second one and the third one. Let us try to see these along with the stereographic projection. So, here you can see that this is your circle, great circle A prime, this is great circle B prime and this third one is great circle C prime. So, wherever this B prime and C prime they are intersecting, that point is BC prime. A and B here, which is AB prime, and A and C, this point is your AC prime. Now, just join these points with the center and you will get here this dotted line, this dotted line and this dotted line. So, the statement that has been mentioned in the previous slide means that this line here AC prime is parallel to the line here, BC prime, this is parallel to this and AB prime is parallel to this line. Now, these views, these are representing the joint traces which are seen in northern side wall from the inside of the tunnel or in the southern side wall from the outside of the tunnel if we look towards 340 degree. Remember that the tunnel was running in the direction from 250 degree to 70 degree, and we have taken this section XX which is perpendicular to the tunnel axis and passing through the center of the net. Now, it can be checked by comparing these 3 angles alpha, beta and zeta of the traces of the planes respectively for A, B and C in the vertical side wall obtained from the stereographic projections with the corresponding traces in the views of tunnel side wall. Again, we take a look to both the views together. See here, this is the angle alpha, this angle is angle beta and this angle is angle zeta. Now, if we try to get the alpha, beta and zeta from this view and try to compare it what we got from this view, they will work out to be same. Mirror image of this figure is going to give us the view of the joint traces in the southern side wall seen from inside or in the northern sidewall seen from the outside of the tunnel when we look in a direction of 160 degree. So, this is different than what we had earlier. In that case, it was northern sidewall seen from outside and southern sidewall seen from the inside, and the direction was 340 degree. Now, it is extremely important for us to understand these views completely in order to avoid the error in an incorrect assessment of stability and in the application of the incorrect remedial measures. So, let us try to see that how we can find out the height of the wedge. So, this can be found by taking a section XX. Take a look in this figure that the tunnel axis is 250 degree to 70 degree. Perpendicular to that is this 340 degree line, and we are looking in this direction, which is the x direction, and this is passing from the center of the net. We need to find the apparent dips kappa and theta of the planes A prime and B prime. So, look at this, how this is determined. Wherever this section XX is intersecting the great circle B prime, which is this point, this angular distance is theta, and this is intersecting this great circle, which is A prime, at this particular point, and this angular distance is your kappa. So, this we can find out from the stereographic projection. Then construction will be done exactly in the similar line as we did in case of the roof failure. So, we take any point, draw the lines parallel to the traces A prime, B prime and C prime, and we get this shape of the wedge, triangular shape like this, and this is the third side. Now, as we mentioned that there are two methods for the analysis of the sidewall failure. We discussed about the first method, how the construction of the stereographic projection is done along with the projection on a vertical plane which is parallel to the side wall, and then we saw that how the height of the wedge can be determined. So, let us try to have a look about the second method of the analysis for the side failure. In this case, these traces A, B and C of the joints in the side wall of the tunnel, they are found by determining the apparent dips alpha, beta and zeta of the planes A, B and C in a vertical plane which is parallel to the tunnel axis. Take a look how. So, we have the three great circles again which are representing these planes. So, this is the first great circle which we are denoting by great circle A. Then this is the second great circle denoted by the great circle B. And the third one is this one, that is great circle C. B and C intersecting here, so this point is being represented by BC. This is AC and here this is AB. Now how to determine these apparent dip? So you see that the tunnel axis is running in this direction 250 to 70 degree. So wherever this intersect this great circle A, this angular distance is alpha. Come to the great circle B and along this axis, whatever is this angular distance from here to here, which is beta, and with respect to the circle C, this distance is zeta. So this is how we can determine this alpha, beta and zeta. And the construction of the true view of a wedge in the side wall using this method too has been shown here, where you can take a look that this angle is alpha with the tunnel side and this angle here it is beta and this angle is zeta. How to determine these? You can take a look here in the stereographic projection and can obtain that. Appearance of the traces AB, BC and AC in the side wall can be established by finding the dips psi ABT, psi BCT and psi ACT of the projections of these lines of intersection on the vertical side wall. How can we determine these dips? Using these expression, we can determine these three values of the dip of the projection. So, tan of psi ABT is equal to tan of psi AB and cos of theta AB. The question is how to determine psi AB and how to determine theta AB, but before that we need to know what exactly are these. So, this psi AB is the true dip of the line of intersection AB, where this theta AB is the angle between the tunnel axis and the projection of the line of intersection AB on the horizontal plane. Take a look at this figure once again. So, psi AB, which is the true dip, how will you find? Where is the point AB? Here it is, because it is the intersection point of the great circle A and great circle B. So, this is point AB and you measure this angular distance. This is going to give you psi AB, which is the true dip of the line of intersection AB. Come to this theta B and read it carefully that it is the angle between the tunnel axis. So, where is the tunnel axis? This is what is the tunnel axis. And the projection of the line of intersection on the horizontal plane. So, the horizontal plane, its projection is going to be this one. So, the angle between these two is going to give me the angle theta AB. Similarly, I can find out the angle theta AC in this manner, and here this angle is theta BC. The expression that we are using to obtain psi ABT, the similar expression we can write for the determination of psi BCT and psi ACT. So therefore, we would need theta BC, theta AC along with psi AC and psi BC. So as I mentioned that psi BCT and psi ACT, they can be obtained in the similar way as you obtained psi ABT. Now how to determine this height h of the wedge? So this is obtained by determining the angles psi BC T prime and psi ACT prime, which represent the dips of the line of intersection as it is seen in a vertical plane at right angles to tunnel axis. So that is why here a prime has been added, because these are the angles which are seen in a vertical plane at right angles to tunnel axis. Have a look here, that you see that here it is psi BCT prime and here it is psi ACT prime. The question is how to determine these two angles, because until and unless we know these angles, we will not be able to determine the height of the wedge, which is h. Take a look on this part of the figure, which can be constructed now because we know these three angles psi ACT, psi BCT, psi ABT, and then we know these traces A prime, B prime and C prime. From the stereographic projection, just draw the parallel lines as I already explained you in case of the roof failure. Follow the same principle and you can construct this. Now this angle psi BCT prime is given by tan of psi BCT prime is equal to tan of psi BC divided by sine of theta BC. So we can we know here what is psi BC we have already obtained, and we know theta BC also. So we can determine these psi BCT prime, and similarly we can get psi ACT prime. Now once I know this and this, I can just take the projection of these points in the direction which is the XX direction and draw a line having an angle psi ACT prime in this manner here and phi BC T prime in this manner. So you will be able to get the location of this apex. Once you know this location of the apex, just measure this distance and that will give you the height of the wedge. Once you know this height of the wedge, and in the plan you can get the base area of this sidewall wedge. In this view you can get the area. So you can obtain the volume of the wedge which is formed in the sidewall and has a tendency to slide. So these were the two methods for the determination of the size of the wedge which can be formed in the sidewall of the tunnel and has the tendency to slide. So this was all about the roof failure and the sidewall failure as far as structurally controlled failure in tunnels is concerned. In the next class, we will start our discussion on rock mass support interaction analysis. Thank you very much.